Alright, this video is about logarithms. Logarithms are pretty easy once you understand all the rules that go with them. So let's get started. Here we have the log base a of x is equal to y. What this is saying is that there are two numbers, x and y, such that a to the y is equal to x. So you could think about this as a to what number will give you x. A few of the properties that are associated with logarithms, if you have the log base a of a, it's always equal to 1. If you have the log of some number raised to some power, then you can take that power out front and have b times log base a of x. Another important property is the multiplication rule. So if you have log base a of x times y, you can split it up into log base a of x plus log base a of y. Similar to this, if you have a ratio, you can split it up into log base a of the top minus log base a of the bottom. You can get to this rule by kind of combining this rule and this rule. So a lot of times you'll see a natural log, and what that's referring to is log base e, where e is a number that's about 2.718. So natural log is just a special case of logarithms, and it's when a is equal to this number. You'll also see log where they leave out numbers, and most of the time that means log base 10. When you get into more advanced math classes, they'll use this to mean natural log, which is kind of confusing, but that's just how it is. I don't know why. So here's a graph of what natural log looks like. It crosses the x-axis at 1, and it goes down to minus infinity as it approaches 0. And it grows very slowly. It eventually goes off to positive infinity, but it's a very slow growing function. So you can't have the log of 0. It's minus infinity, and you can't really have the log of a negative number unless you get into imaginary numbers, which I'm not going to get into. So here's an example of using the power rule. If we've got y is equal to the natural log of x to the 7th, and we want to solve for x, then we can either say use the power rule and take the 7 down in front, then divide by 7, and then we exponentiate. We say e to this power is equal to e to the natural log of x, but e to the natural log of x is x. So another way we could have solved that problem is just exponentiating right away and saying e to the y is equal to e to the natural log of x to the 7th, which is just x to the 7th. And then taking the 7th root, which gives us the same thing. So you can usually solve these in a couple different ways. Here's an example of using the splitting rule. So suppose we're trying to solve for y, and we have natural log of xy equals 5. Then we can split this into natural log x plus natural log y equals 5. Subtract over the x, and then we exponentiate again. So we'll have e to the natural log of y is equal to e to the 5 minus natural log x. You want to make sure to remember that when you exponentiate like this, you have to take the entire side of the equation and put it in the exponent. You can't just split it up, because when you want to simplify this form, you break it into e to the 5th times e to the natural log x. So of course e to the natural log y is just y, and then we can use the power rule, or the exponent rule here, and bring this negative sign up here, so it's natural log of x to the negative 1, which is just natural log of 1 over x. So e to the natural log of 1 over x is just 1 over x. And so we have y is equal to x to the 5th over, or y is equal to e to the 5th over x. I hope this helps clarify some of the log issues.